Right, we'll get started. Welcome to this session of 2012. I've got 10 lectures with you to teach you a little bit about quantitative geography and an introduction to geographic information systems. So it's primarily about quantitative geography in a sequence of lectures. You've probably got some questions in your mind. Those 4 questions are there, perhaps pertinent. Who am I? You're probably asking. What's this set of lectures about? Do I have to pay attention? And why are GIS, Geographic Information Systems, and quantitative geography your passport to a better life? Remember this date, February the 5th, 2014, because it could be a life changer in your careers. Okay? And I'll try and explain why before this morning's lectures. Okay, let me try and answer some of these questions. Okay, my name is Professor Stuart Fotheringham. I'm a professor of quantitative geography. For the record, my office hours are Tuesday 2 till 4. I won't say except today, unless I'm actually on staff meeting today. But generally Tuesday 2 to 4, or by appointment, so just email me if you didn't see me outside all the time. I was a teaching assistant for this course, Gina Martin, who's standing up there, fresh from Canada. And she has office hours on Wednesday, 10:30 to 11:30 in room 14 in United College. Now, most of you have probably never been anywhere near room 13 and 14 in United College. That's what part of the Centre for GeoInformatics, which is housed within the Department of Geography and Sustainable Development. I'm director of the centre, and it's a very innovative centre within geography program. It's the only one in the UK that specialises in geoinformatics. So you have a very privileged kind of opportunity here to avail yourself of these modern techniques, which leads to, as I'll show you in a minute, lots of job opportunities. People who do this kind of work, geoinformatics, are very much in demand in the job market in lots and lots of different areas. Okay, that's why it's important. So where are we? We're in United College, so the way to get to my office is to go into the quad, to go into that door in the corner, marked with an arrow at the bottom, and my office is that one at the top looking over the quad. It actually looks over the back into the sea as well, so we have all of that. My office is all that top bit of that building. So if you just go in United College in that door and go up either set of stairs, there are 2 sets of stairs when you get in there, go to the top and then look for room 13, or if you're looking for Gina, look for room 14. They're at the end of the corridor. Okay, that's how you find us. Okay, there's a website if you're interested in what the centre does, the Centre for Geoinformatics. The website there, www.standrews.ac.uk/geoinformatics. You can find out all about us, all the people involved in the centre, what we do, the kind of research we do, and the activities we do. So it's a big part of the department. And as I said, you are in a privileged position to have the opportunity to take courses in geoinformatics. And I'll explain a bit more about that in a minute. You've got a leaflet in front of you that I will talk about as well. So what is geoinformatics? For many of you, that might be the first time you've heard of it this morning. Basically, geoinformatics involves any aspect of the capture, storage, integration, management, retrieval, display, analysis of, and modelling of spatial data. Spatial data are data which contain locational information as well as attribute information. So if something happens somewhere, we have a record of what happened and where it happened. So these data typically come with XY coordinates or some means of geocoding the data. So we know where they happen. We can map them. That's what geography is all about. If you want a one-liner definition of geography, it's the study of the processes that generate spatial data. Okay? Or it's a study of the processes that generate the world, the things that we observe in the world around us. Those things can be in the physical world or the social world. So that's what we do as geographers. We study not just the outcomes of the processes, that's just description. We study the processes. We can get a handle on the processes by observing what happens in the real world. That's how our key. We want to try to infer something about the processes that have generated those data. So no matter what your area of interest is, whether it be health geography, crime, the environment, etc., we all do the same thing. We observe something and we want to know what caused that. And what caused that are the processes that we try to uncover through various types of analysis. So geoinformatics is all about recording, processing, viewing, and disseminating geocoded attributes of the environment. And I said the environment can be the physical environment and it can be the human environment. By the way, this lecture will be available on Moodle as soon as I've finished here. I will make my lectures available on Moodle immediately after class, so you don't have to take notes on everything I say. Okay, so basically what we do, we try to use techniques to find out where things are. We want to know where things are in relation to other things. So it might be incidents of disease, for example. We might want to map those incidents. It might be a rare disease. We might want to look for links that the mapping suggests to us about a source of that disease. It could be a pollution site, for example. And we do that to ultimately to make more informed decisions. We want to do something about what we observe. We want to influence it in some way. And for that, we need to understand the processes that are generating what we're observing in the real world. And those things are true of every type of geography that you study. So the kind of research we do involves data collection, and there are all kinds of increasingly detailed types of equipment to collect geographic data. We're actually awash with data. The whole world is now awash with data. I'll talk about this in just one minute. Absolutely massive amounts of data are being collected every day. Most of your tweets are geocoded, for example. Telephone calls, any kind of Foursquare check-in. All of these things are new forms of geographic data. We've got machinery equipment that will LiDAR, for example, which will generate literally millions of geocoded points a second. We're absolutely awash with data. What we're not awash with are people who can actually analyze those data and make some sense out of it. So lots and lots of businesses, lots and lots of government agencies, etc., are awash with data. That's no longer a problem. It used to be a problem, it no longer is. And most of that data is spatial, geographical. What we don't have are people who can actually take those data, make some sense out of them. They're obviously very noisy data, lots of noise in them. What we're looking for are people who can identify patterns within those data. Interesting things. So we want to convert the data into information. That's where the bottleneck is. That's what we're short of at the moment. People who can do that. There's an increasing demand for people who can do that. And because most of the data is spatial, we're looking for people who understand spatial data. And that's you guys. So we're able to collect vast amounts of data. Some of you, at least in the first year course, had experience in doing GPS traces. You went out and recorded your traces within St Andrews, I think, and mapped these things. There's lots of other remote sensing devices. Volunteer geographic information, OpenStreetMap, for example, is an example of volunteer geographic information. People are contributing geographic data. We want to visualize this quite often. We want to see what it looks like. So there's mapping involved, there's visual analytics, things like new equipment, touch tables, etc. coming in. And then we want to analyze those data. We want to find out what's produced them. And that's where a lot of analysis comes in, high performance computing, types of spatial modeling, spatial analysis, which is what this course is a bedrock of spatial analysis. Understanding data and trying to separate the signal in the data from the noise. Because we know that there's a lot of uncertainty, a lot of noise in the data. We want to try and capture that uncertainty in a way. So what we're going to do today, this week, or next week, or the next 10 lectures, is try to understand some basics about the analysis of spatial data. And people often think quantitative analysis is all about almost being robotic. It's not taking into account feelings, etc., etc. It's all kind of right or wrong. That's completely false. That's a sort of almost a rumor spread by people who are enumerate and don't understand what it's all about. It's exactly the opposite. Spatial data analysis, and particularly what we're going to cover in this course, spatial statistics or statistical methods, is all about being wrong. Okay? We know that we are not 100% right. It's all about assessing how wrong we are and what the chances that our conclusions that we've drawn from the data are wrong. And that's a very useful bit of information to provide. So if you're saying, I predict this, you shouldn't just stop there. You should say, with this kind of degree of certainty. And that degree of certainty is rarely, if ever, 100%. Something less than that. So it would be useful to say, I think this is what's happening, but here's a chance that I'm wrong. And statistics is all about assessing that chance that we're wrong. So anytime somebody says something to you about this caused that, just stop and think, well, are you sure? What's the chances that you're wrong in that assertion or that assumption? And that's what we're going to learn in the next 10 weeks, is to how to measure this uncertainty, this chance that we might be wrong. So statistics is not about being right, it's about being wrong. And just get that kind of idea in your mind. So this set of lectures is to get you to think, and that's the important thing, is to think statistically. It's not a test of your memory in any way like that. My memory isn't particularly great on these things. It's understanding that's important. There is no exam attached to this section of the course. It's project-based. So you'll be given, and I'll talk about this later on in the course, you'll be given a data set to analyse, and it's up to you to come up with ways of analysing the data, which is very much akin to what you would find in the real world. You'd be given a data set and try to find some interesting patterns within the data set. But that will be explained more later on. But it's not a final exam where you come in and you have to memorise lots of equations and things. Nobody does that anymore, basically. It's also to get you to understand uncertainty. Things are not certain in this world. Hardly anything is certain. A few things are, but very, very few things are. Most things are uncertain. There's a probability attached to something. You have to understand that. It's also to get you to understand evidence. If you're putting forward, or somebody's putting forward an idea, what are they using to support that? Is it some kind of vague statement about, I saw a few newspaper cuttings and I think that the journalists suggested this. I don't know, something about homeless people in society or something, and somebody's done a newspaper report on them. What evidence is that? Is that very hard evidence? Is it soft evidence? Etc. Or I interviewed 3 people off the street, and these 3 people suggested this. Or I had a focus group of 10 people, and they suggested this. Is that hard evidence or soft evidence? What degree of believability is there in that? So we have to understand what evidence is and how strongly you can believe anything that somebody says, drawn from various types of supporting evidence. Some evidence that geographers use is, I think, incredibly weak. So there are lots of current debates that involve all of these things about uncertainty and evidence. Variations in insurance rates. Should there be variations between males and females, which has now been removed for car insurance, for example? Is there a link between obesity and health? What link is that? DNA evidence, how do we understand that? Climate change, what are the pros and cons? Obviously big debates about that. What kind of evidence is there and how supportable is it? Okay, number 3, you have to pay attention. Yeah, the material in this course is cumulative, so don't miss a lecture. Okay? You can skip other people's lectures if you want, but don't skip these ones, because if you miss a lecture, you will be behind. So pay attention and don't miss lectures. It's very important. This course is just about basic statistics, but you have to go through the basics. Some of you may have done this already in other classes. Some of you won't have done this. So we're all starting off with a sort of clean sheet, as it were, and we're going to go through right from the beginning. We're going to start with probability basics. Stick with it. Have a positive attitude. Okay. Appreciate that you have to go through the basics. It's a bit like learning to read. You have to learn the alphabet first. That's what you're doing in this class. concepts are more important than the equations, so don't get bogged down by the formulas. Okay, the formulas are always in books or on the web, etc. You don't need to remember the formulas. You need to understand the concepts. It's important. But recognize that mathematical symbols are there not to confuse, but not to be put there by some evil person who just wants to annoy everybody. They're there to make life easier. And if you accept that premise, then you won't be put off by symbology, mathematical symbology. Okay? They're there to make our life easier. Okay. And then the last bit, which is the rest of the course, the lecture, sorry. Why are geographic information systems and quantitative geography your passports to a better life? Well, first of all, it describes things more easily. Yeah, we need to. There's loads and loads of data. We want to map these data, we want to integrate them, we want to see how one data set is related to another. It's much easier to do that within the framework, for example, GIS, Geographic Information System. We want to be able to model, mathematically model things, processes, in order to understand what they're doing, in order to predict the outcomes from these things. What if things change? What happens? Can we predict the effect of that change on the system? We can only do that if we can actually model the relationships between variables. These concepts apply to all spatial data, okay? And spatial data are everywhere, in all kinds of walks of life. So geographers are becoming increasingly, well, quantitative geographers are becoming increasingly employable in all areas. The demand for example, my PhD students, master students, etc., is enormous. Because people want people who can analyze data in all areas. The data sets are becoming huge, absolutely massive. We're drowning in data, and we need methods to convert data to information. We now collect data every couple of days, which is equivalent to all the recorded works in history. So all your tweets are recorded, all your any kind of social messenger kind of activities, they're all recorded, it's all information. Every time you click on a Google page, it's recorded. That's all information. Somebody somewhere is analysing. And we're drowning in it. We're collecting huge, huge volume of data. And we need people to help understand what those data shows. And ultimately, that means jobs. It used to be the case when you came to university, it was a sort of fairly rare event. And therefore people with degrees could get jobs in kind of any area, just as sort of a unique card, almost a passport to a job. It was some kind of filter. That's not really the case anymore. Lots of people have degrees. The filtering process now is what kind of degree you have. Have you got something that has skills that are in demand out there in the real world? There are not many jobs for people who can deconstruct Jane Austen. Okay, I've never seen any advert in any newspaper anywhere that says something like that. Okay? There are lots of jobs in the area that I'm teaching you now. Okay? So just be aware that if you're interested in a job at the end of this, quantitative geography, GIS is the way to go. And it doesn't matter whether you're in physical geography or human geography, it's exactly the same. I'm going to give you some examples of this. Also, I'm going to, you've got a leaflet in front of you, which is about the centre that I run, but it's also about this thing called QSTEP. QSTEP is a program that is just starting this year. It's funded by the Nuffield Foundation, the Economic and Social Research Council, and the Higher Education Funding Council of England, to promote quantitative methods in social science. It's a big program, £15 million worth of investment over 5 years, and we at St Andrews, our department, and the Centre for GeoInformatics is privileged to be one of the centres selected for this. And you guys are in a privileged position because this is the first year of its operation. You're the first people who can take advantage of this program. So the QSTEP program, the rationale behind it is we've got lots and lots of social scientists. They come out and they don't really have that many job skills. And we want to change this. So there's a big push across all the social sciences, not just geography, for people to have more That's where the jobs are. And we have a large grant that is funding this kind of lecture series and also subsequent ones within your program. You're the first group who can take advantage of this because we're introducing a set of new courses that will lead to a very good set of training modules in quantitative geography and geographic information systems. And this is what it looks like, and I think this is in the leaflet in front of you. Basically, the right-hand side of that diagram is what you should be looking at. The left-hand side is what used to happen in geography, which was a sort of a smattering of quant methods courses, but not very well organised. Now it's becoming highly organised, and there's a progression of courses that you can now take. So in first year, you did some, you had some lectures in GeoInformatics and GIS, and you did some capturing of spatial data with GPS trackers. In 2011, it's 2011, there's some materials. 2012, this is this course. And then next year, in third year, in 3201, there's Unit 2A, which is a statistical analysis course coming on from this one. So it builds upon the material I'll be teaching you. And multivariate statistical analysis. And then there's 3201 Unit 6, which is a follow-on from the GIS kind of course, spatial data capture. There are 2 units there that you can take in third year. There will also be a new course offered next year in third year called Remote Sensing for Environmental and Social Research. That will tell you all about the technologies involved in remote sensing, how to capture data and how to analyze data. We're looking at various social and environmental processes. Then in fourth year, we have new options available to you. One is advanced topics of geoinformatics, looking at big data, how we can cutting edge techniques for analysing large data sets, and also the new course health geoinformatics. So if you've got an interest in health at all, and there's a lot of obviously demand for people who are in that area, looking at patterns of spatial patterns of health, spatial epidemiology, etc., then that's the course for you. And you can also obviously do, the idea is, if you take these courses, you'll be really well prepared to undertake a dissertation in these topics. You don't have to go out and collect data to do work in spatial analysis and quant methods, because there's loads of data already being collected. So that saves you an awful lot of time. What we need are people who can actually take those data sets and analyze them in some interesting way. And there are all kinds of data sets out there which we can provide for you. Now, if you do all of that, if you take these courses, for the very first time, you have the opportunity to get a new degree. And this is just in the process of being worked through the university, but it will be available to you. You can then have a BSc or an MA, depending on your area of interest, which is called Geography with GeoInformatics. And you guys can avail yourself of this for the very first time. You'll come out with not a BSc or an MA in Geography, but a BSc or an MA in Geography with GeoInformatics. And that with GeoInformatics is going to get you a job. So if you want to do that, and if you're interested in that, then that's the sequence of courses that are on there that you need to take. So you've already done the first year course. 2011 and 2012 are compulsory, so you're taking that right now. 3201 is compulsory, Unit 2 and Unit 6, take those, and then take the course in remote sensing, and then take one of the 2 options in fourth year, do an undergraduate degree in this area, something you're interested in, and you will then have all the qualifications you need to have this degree, geography with geoinformatics. So you're the first year that can avail themselves of this opportunity. So be aware of that. If you're interested in this kind of area, or you're interested in getting a job at the end of your career, then think about this progression carefully. Okay? All right. Okay, let me just talk about the presence of spatial data. Why what we're doing is important. As I said, spatial data are everywhere. The census contains huge amounts of spatial data. 60+ million records on approximately 50 variables. It's all out there, and the 2011 census is coming on stream. So when you come to do a dissertation or some project, it's all out there, all available online. You can go and collect it, analyze it for the first time. You can be an innovator and find out what's going on. Customer databases, lots and lots of Big firms now collect information on their customers, where they live. Every time you sign up for a loyalty card, etc., they know where you live and they know your shopping habits, they know what you're buying. Every time you click on Google, they know what you're doing, etc. Companies in the UK hold records on over 30 million individuals. You're all being tracked in many ways, and that's just going to increase. Traffic flows, the volumes of traffic on roads by time of day, day of the week. There's old-fashioned meters that do this, there's travel diaries, and there's GPS receivers. LiDAR, light information, light detection radar, laser detection radar. It's terrestrial, it's airborne, it's rapid collection of detailed data on features. So this is where we have survey machines that will capture literally millions of geocoded data points a second. Your phone, we're increasingly doing everything. We've all got smartphones with GPS chips in. We can find out where you are fairly easily. There's linkages to cell towers. The true way of doing it is to find out which cell tower your phone is connected to, trace your activities. That way, we can do a trial operation from several cell towers to pinpoint your location more precisely. And you've seen that happen when somebody goes missing, for example, the police are able to recreate their journey to find the cell phone. And your cell phone increasingly is being used by people when you go into restaurants, etc. Some places have facility, Bluetooth or whatever, to check your phone, find out who you are, what kind of things you do, and then send you messages accordingly. So we're increasingly being monitored, and that's just going to be part of reality, whether we like it or not. There are good points and bad points about this, but it's just going to happen. We've got technology with us now that's going to be used to monitor our movements. So it's all providing data to somebody to analyze. Google, you've seen what Google will provide. You've seen that Google Earth, obviously, Street View, there's things like Flickr, Facebook, Apple 3D imagery, all kinds of data being provided, but also all kinds of data being collected about this. And some of it legally, some of it legally. Health records, there are patient records, the hospitals obviously collect data on where you live, who you are, what kind of diseases you have, and there's also incidence of disease. So there's patient records about demand for hospital services that need to be looked at. Where should we look at GP surgeries? Where should we look at hospital facilities to minimise travel time or emergency visits, etc. to hospitals? The incidence of disease, that's a spatial dataset. Perhaps the incidence of childhood leukemia, a very rare disease. We want to analyse the patterns to see if there are any environmental factors perhaps that are leading to the patterns that we observe. Satellite remotely sensed imagery, there's lots of satellites up there. Now that we've been used, that land use cover, obviously the military have been users of this, we can monitor things in some cases in real time, in some cases 24-hour delays, etc., depending on the orbit of the satellites, but we have access now to huge amounts of data about the Earth. The satellite GPS, we're all aware of GPS, the utility of it. We're all still using, most of us still using the US GPS system, which is a constellation of about 28 satellites in space, launched in 1978. Some of those satellites are getting very old and are being replaced. You are probably aware that the European Space Agency is launching its own constellation of satellites called Galileo. It's increasingly behind time and increasingly costly. It costs about €4 billion so far. It's going up on a weekly basis. It's going to give us a lot more accuracy in terms of our GPS locations, and it's going to make us independent of the US system. Russia's already got GLONASS, so mini constellation of satellites. China's got Compass, the equivalent one. And the reason that places are doing it, putting these satellites up, is that there's a huge market for GPS, for knowing where you are on the Earth. So the European Commission, for example, estimates 4 billion receivers by the end of this year, and a market worth €300 billion. Just think now about how ubiquitous GPS is. compared to 10 years ago. We all take it for granted now that there's GPS on our phone or camera. So we've got in-car navigation systems that have been around now for a long time. We just take it for granted. Somehow we get in our car and magically we're connected to a set of satellites.